Last time, you learned how data finds the right machine. The IP address gets it to the right computer. The port gets it to the right service. But that is only half the story. Once the data arrives, the two machines have to understand each other. The rules they use to do that are called protocols. And a few of them are where almost all security work happens. I'm Unsalted. I work in cybersecurity. Let's get into it. So, what is a protocol? Picture two people who agree to speak the same language before they talk. That agreement is why they understand each other. A protocol is the same thing, but for machines. It is just an agreed set of rules for how two computers share information. Both sides know the format ahead of time. So, what one sends, the other can read. Today, we cover the four you will see the most.
TCP, UDP.
The first two are about how data gets delivered. They're called TCP and UDP. Starting with TCP. Think of a phone call. You keep checking the other person can hear you. TCP works the same way. It sets up a proper connection first. Then it checks that every piece of data is arrived. If a piece goes missing, it sends it again. Most things use TCP. Loading a web page, sending an email, you cannot afford missing pieces. Next, UDP. Think of shouting across a room fast, but you do not stop to check every word landed. UDP just sends the data, no setup, no checking. That makes it faster. So it is used for video calls and online games, where speed matters more than a little lost data. Here is why a defender cares. Because UDP does not check anything. Attackers sometimes use it to flood a target. So knowing which one an alert involves is already a clue.
HTTP, HTTPS.
The next two run the web, HTTP and HTTPS. HTTP is how your browser asks a website for a page, but plain HTTP has a problem. It sends everything as readable text. If someone is sitting in the middle of that connection, they can read all of it. What you type, what the site sent back, all of it. HTTPS fixes that. The difference is one letter. The S means secure. It is the same thing but scrambled. Anyone who intercepts it sees only nonsense. Scrambling data like this is called encryption. It is what keeps your passwords private on way across. So here is a point for a defender. Seeing plain HTTP, where you expect a secure version, like a login page sending a password as readable text, is worth a closer look.
DNS.
Now, the most important one for security, DNS. Here is what it does. You remember website names like google.com, but machines do not use names. They use IP addresses. So something has to turn the name into address. That something is DNS. Think of it as a phone. You give it a name, it gives you back the number. Here, the number is an IP address. And you can watch it happen. Let me show you. This is DNS live. I gave it a name, google.com. It handed back the real IP address that name points to. Up here is the server that answered. Down here is the address. This happens silently every time you open any website. So why does DNS matter most for security? Because almost every attack uses it. Think about what malware does once it lands on a machine. It needs to contact the attacker's server to get instructions. But first, it has to find the server's address. So it does a DNS lookup, the same lookup you just watched. The malware uses the phone book, just like you do. This is why defenders watch DNS closely. A normal machine looks up normal names, but a machine asking for a strange, random domain names over and over is a classic sign it is infected. So let's pull the four together. TCP and UDP are how data travels, the careful way or the fast way. HTTP and HTTPS run the web, in plain view or encrypted. And DNS turns names into addresses and sits at the center of almost every attack. Next time you read an alert and see these names, you will know what each one means. You now have the addresses and ports from last time and the protocols that run across them. You are starting to read a network the way a defender does. In the final part, we put it all together. We follow how a real attack moves through a network step by step. If this helped, subscribe. See you in the next one.